talk about Claude Code and what were the key design principles which was used to build Claude Code. So I have been using Claude Code for quite some time now, and I was curious about the design of like what design principles were used to build Claude Code because it's really good. It is like one of the agents which I have used, one of the agents which I've used which works very reliably, and it I use that to implement my features or my bug fixes. I use that in my day-to-day life. And I really was curious like what were the design principles which they used to build such a reliable agent, and what can we take away from it to build our own agents and apply to our own agents. So I will walk you through the key design principles used to build Claude Code. Now, the first principle which Anthropic follows is that Claude needs the same tools that every programmer needs or that every programmer uses in their day-to-day life. So, think of it this way: if a feature is assigned to you, what are the first steps which you would take before implementing the feature, right? The first thing is you are going to search the code base for the relevant code if that feature is implemented, is an existing feature and there's an enhancement which you have to do. So you're going to search the code base to find the relevant files, what has understand what is already there in the code, and then how are you going to add that enhancement on top of it. Or if it is a new feature, you are going to check how that feature is going to be implemented in the current code base. What are the new files you are going to add, new files, new classes, functions, interfaces, all of that, and how is it going to be integrated with the current code, what would be the impact on the current code, what existing files you would modify, right? So your agent should also need to have access to all the appropriate files in the code base. It should be able to search those files, write and edit in those files, and do all those things which a normal developer could never developer does. So it needs to be able to find appropriate files in the code base, write, edit files, lint, run the code, debug it, and take those actions iteratively until it succeeds in building the feature or it succeeds in the desired goal. So, by giving access to users' computer via the terminal, the Claude Code or the agent would have whatever is needed to write code like a programmer would write. Now, the next big thing is the agent loop of Claude Code. So, the agent loop has three things into it. First is gather context. So, gather context is like it's similar to the example which I took about the coding agent. So, like when you are writing a code, the first thing which you would do is you would fetch the relevant context which is needed for you to implement that. Like you would get the requirements clarified. If there are any questions or queries, you would reach out to your product owner or any one from the business side to get clarifications. Now, in terms of an agent, how can that agent gather context? One is by searching the relevant files, as we talk about. Like the first thing is the impact analysis which you do when you are building an agent, right? So you are going to search the file system, figure out the relevant files, what impact it could have, or what is the existing code. You're going to understand and gather context around that area. Then second can be semantic search in terms of agents. So we have heard of semantic search. RAG was really popular last year, where a lot of people, like a lot of coding agents, when they came out, people were starting to use RAG on code repositories to do similarity search, and then use LLMs to uh, use that context to provide to LLMs, and then LLMs can use that information to generate code. But that was way too complicated, and it was inefficient, it was less accurate. Semantic search has problems of relationships. You cannot uh, define relationships between the chunks. Like you can define it using graphrag, but a normal semantic search will not fetch the code which has relationships. Like a very simple example is in your code, You may, if you're looking for a login functionality, so it may search the function related to login for you, but your login would be using some middleware which is there in some other file. Now it, for you to understand, or for your coding agent to understand that entire code, it also needs access to that file which has the implementation of that middleware. So semantic search can miss out on those things, so it's less accurate. Okay, so the next thing is subagents. So Claude Code also uses subagent to gather context efficiently. Uh, so subagents are useful for, one is like enabling parallelization. So let's say you have given Claude Code a task to implement a new feature. Like I'll give you a real world example which where I used Claude Code and it did a fabulous job. I was implementing the agent to agent protocol, and agent to agent protocol is a fairly new protocol which is introduced by Google. And so I wanted to expose my agent as an A2A server. And what I did was I gave Claude Code the link to the documentation of the A2A protocol, and I instructed it to read through the documentation first and then figure out what are enhancements uh, we would need to do in our code base to expose our agent as an A2A server. Now, this task, it can be broken out into two subtasks. One is go on that web page, find the relevant information of how to expose an A2A server, how to use that SDK, and things like that. And the other task could be analyzing the current code base to figure out how our current agents work and how would you expose that agent using the Google's A2A protocol, right? So this two, like analysis of the current code base and understanding the documentation of the A2A, can be two parallel tasks which can be run by two sub agents, right? It also, that makes it more efficient, fast, and a better way to perform task. Another thing is also it helps manage context. So each sub agent has their own isolated context window, and what they do is the main agent or the orchestrator agent will send tasks to the sub agent. The sub agent will use its own context window to like use its own context window. It will have its own tools. So it will perform the task, and it will only send the relevant information back to your orchestrator agent. So in this case of reading the documentation of the A2A protocol, it is not going to send the entire documentation back to the orchestrator. It will read the documentation and extract the relevant information which would be needed for implementation and only send that back to the orchestrator agent. So it helps manage context very efficiently. Now, the third thing which it has is compaction. Compaction is a feature where it automatically summarizes the previous messages when the context limit is about to reach. Like, for example, if the context limit has reached like 90%, at that point it will automatically compact the previous messages. Compact means like just summarize the previous messages. Then the next thing is taking action. Now this is where it gets interesting. So taking action, you like in the world of agent, you take actions via tools, right? Tools or MCPs. So you need to define tools for primary actions which you want the agent to take. In our case, it would be writing files, like writing code. So that would be the primary action for our coding agents. Now claude Claude SDK, the agent SDK, in general provides bash and script as a general purpose tool for all the agents, because bash and script tools can be used for any task. Like it is not specific to your coding related task, it can be used for non coding task as well. Like for example, if you are building an email agent and you give an instruction saying that can you find me an invoice for my can you find me an Uber invoice for last month, or you want to search something in your email. Now it can just create using bash scripts, you can just create a small script which can actually search through your emails and find the relevant information. So bash bash scripts are really useful for non-coding tasks as well. Then the third thing is code generation. Now, code generation in terms of coding agents is obviously, it's a very useful tool to have. But even for non-coding tasks, for really complex operations, code generation is a very useful tool. So, like the previous example, right, the agent can write scripts to perform searches, to build your ppts, to convert pdf into text, or to extract text from some image, or from some pdf, right? All of these tasks, all of these tasks, you can write code. And code is the best way to perform action reliably. So code generation is one of the tools which your agent should have access to. And then last is MCPs. MCP is Model Context Protocol, which was released by Anthropic, I think last year or last to last year. Like it has been there just for around an year now. And MCPs is a way of making your tools accessible for everyone. It is like a plugin integration for tools. Then the last thing is verify your work. Now, the agents that can check their work and improve on their output automatically are fundamentally more reliable. So, once the agent generates an output, you define rules for your output. Like, I want my output to, let's say, if you want, you can define rules such as my output should have three attributes. Like if I am generating a post for LinkedIn, I can define rules like I want my title to be 50 words, and then my content should be should not exceed like 500 words or 1000 words, whatever. And like you can define those clear rules which the agent can use to validate its output against. And you can also give examples of failures of rule. Like if let's say a very worded title, that's a straight no, like that's a straight reject for me. I wouldn't want my title to exceed 50 words or something, right? So like clearly define rules and clearly define failure scenarios so that the agent understands how to validate the output, its own output. Then visual feedback, you can click screenshots and then send that screenshot back to the agent for the agent to verify the output visually. And the last way to verify your output is using LLM as judge. So LLM as judge is like having another LLM model uh, judge the output of your agent, and then giving feedback to the agent for like corrections and improvements. So this is the loop which the Claude Code agent follows, or any agent which is built using Claude Code SDK uh, can follow this. Like any agent ideally should follow this loop of gathering the context, taking action, and then verifying the work. Now, on top of this, like a lot of things which Claude Code does is, one is it maintains its to do. So like why Claude Code works the way it works is like, one is it prefers simplicity over complexity. So the agent has been given instruction to do simple things first, and it maintains everything in a to-do list. So there are system reminders which are sent to the agent after every few tool calls, I think, where it says that there is, if your to-do list is empty, it says that your to-do list is empty, but don't tell the user because user is aware of it. And if it is performing certain actions, so it will send system reminders like it is better to use a to do create a to do list for the tasks which you are planning, and update the to do list once the task is completed. So after every few tool calls, there is a system reminder configured which keeps reminding the agent to maintain the to do list, update the to do list, so that it stays on track. It says stays on track for the given goal. And that also gives transparency to the user in terms of how the agent is thinking and what actions the agent has taken. Then the other thing is you can always interrupt Claude Code. So you can see what the to-do list which the agent has prepared, right? And if you think that the agent is sidetracked, or it is not taking the efficient route, you can always interrupt the agent by giving instructions that, oh, I don't think you need like 5 steps to do this. You can do it in 3 steps, or whatever, right? So you can always interrupt, and it always takes those instructions into consideration, and it will refine the plan. uh, and like it works in continuous loop. So that is one of the good things. Another thing is they use markdown files. They don't, like, they prefer markdown files over databases for memory. So everything is like an MD file where agent manages its own context. So it can write to the markdown file. It can read from the markdown file. So that helps uh, the agent to work more reliably. And then keeping humans in control by enabling agent autonomy. So, as I said before, agents' ability to work autonomously is what makes them valuable. But humans should be able to retain control over how their goals are pursued. So that's why when you start, if you have worked with Claude Code, you would see that it is very annoying that it will ask for every little action, it will ask for your approval. So by default it has read only permissions, and then if it has to take any action which is related to modifying the code or any system files, it will ask permission from you. And once you give permission, then you can do those settings, like you can give permission to Claude Code to write files in your folder, or you can specify which folders it can freely access, like write files, edit files, and all of that. So but the control is still with the human, and you can give the permission to Claude Code depending on your goals, and depending on your trust factor. So I think that was it.